everybody. As you may notice, I am dressed up as a cow. So happy Halloween on Saturday. This was not my choice. This was my daughter's choice. My daughter is going to be a cowgirl, and so she wanted me to be the cow. And so here I am in a cow suit. So please continue to try to take me seriously, even though I am dressed like an animal. Do all of you have Halloween costumes lined up yet? Some of you? Yeah? All right, we'll have to show them off or something like that. So, all right, as usual, you're looking for the tasks to complete for Unit 2, Lesson 6. So please look for tasks to complete for U2L6 under assignments or on the Canvas homepage on the weekly calendar. Should all be there. As usual, we'll start with a opening question. You know what? I think I'm going to change it now, last minute, because Halloween is coming up. So let me come up with a new one that. Give me 1 second here. All right, let's try this. So here's the question. If you could get a Halloween costume, or if you have a Halloween costume planned, or could get a top quality Halloween costume, who or what would you dress up as? So either share what your costume is going to be this year, or if you didn't plan anything, what would be your ideal costume if you could get like the best version of it? So think about that for 20 seconds, and then I'll throw you into breakout rooms. All right, we'll come back together in 2 minutes. Rooms are open. Review. Everything's looking pretty good on my end. Just to share my screen here real quick. Drawings look awesome. I'm going to put Grace Kim on the spot. Here's a really exemplary one that she did. And this is pretty much what your drawing should look like if you were really following the instructions like word for word. And I'll be looking for names of your star and your planets. But again, if yours is a little off from this too, it'll be okay as long as you have your calculations and things like that. I'll grade those soon. You had the orbit simulator quiz that you had to complete. And again, it's looking pretty good. The key takeaways that I want to make sure you had from this is what type of orbit does it initially start with? It's circular, which is not the most realistic form of orbit. It's not what we usually see. And by adjusting the mass, you can see that it changes. And I'm kind of hoping that, again, you're associating mass with gravitational force, right? And so they're proportional. If you increase mass, like if we make our lunar mass higher, the moon actually starts to be pulled in a little bit just because that gravitational force is increasing. And then that gives us an elliptical orbit. The key thing to notice about elliptical orbits is that the speed changes, right? That objects in the elliptical orbit move a lot faster when they're closer to their source of gravity, right? The planet they're going around or the star they're going around. And then they slow down as they kind of loop out further away. And then you had to reset the moon. And if you make it lighter, it floats away. It's lost. And there's decaying orbit and expanding orbit and that kind of thing. So, and the Ed puzzle, let's see, is looking pretty good. Looks like most of you have gotten through it. If you haven't, please do so. Were there any questions or concerns or anything you got stuck on in any of those assignments? Cool. All right, again, today we're going to be exploring orbit in a little more detail. Before we get started on that though, or our first review activity will be a little Kahoot that we'll play. Just want to make sure I'm following the schedule correctly. Yes, okay. So once again, I'll share my screen and you all know what to do. Okay, game pairing is 5328257. Please use your name or something close to it so we know who everybody is. All right, looking good. There's 14 of us here. There we go. All right, let's get going. This will be short. I think it's just 4 questions. What is tangential velocity? Very good. Majority of you got it. It is moving parallel to Earth's surface, and that's the whole time. So you're moving around Earth because Earth is curved. Kayla in the lead. Here we go. True, false. The moon orbits Earth at a consistent velocity, same speed at all times. Very good. That is false. If that were true, the moon would rise at the exact same time every single day. We could, just like we have clocks, we could time things around it. That is not actually the case. It's a little bit slower. All right, Kayla's still in the lead. Here we go. Increasing the mass of a planet will cause satellites orbiting it to do what? Very good. This aligns pretty much exactly with one of those homework questions from the simulator. It would orbit a little bit closer. If you're increasing mass, you're increasing the gravitational force. All right, Kayla's on fire. Here we go. Last question. What is eccentricity? Very good. It is the measure of how round an ellipse is, and that was part of the homework that you were doing, just measuring how circular it is. Nicely done, Bryce. Sophia. Good work, Kayla. Awesome. All right. Hopefully that was some fun review. Now, I know I keep throwing Ed puzzles at you, but the next task, number 4 right there, gravity visualized Ed puzzle, is what I would like you to work on next. There's just a video that you'll be watching. You'll be watching 4 minutes and 48 seconds of it. There are 4 questions associated with it. Again, if Ed puzzle freezes for you or doesn't work for you, on the 3rd bullet point there, I've got if Ed puzzle does not work. Here's the original video on YouTube. You just need to watch the first 4 minutes and 48 seconds. And I made a Google form where you can still answer the same questions that everyone else is answering in the Ed puzzle. We'll review those together once we've got it done. Any questions on that? All right, 10 minutes to work on the Ed puzzle. But once I see enough people done with it, we'll come back together. So go for it. All right, feeling good there. So it's, to me, kind of mind-boggling about how every single planet orbits around our sun in the same direction, right? Why is that? And it's because when the nebula was forming, things were moving in all different directions. You see him launch all those marbles in 2 different directions, but eventually there's a dominant direction, right? That there's collisions, but eventually there's some point where everything is moving that one way, and everything that was moving the opposite way has been collided with or eliminated or knocked out. That's the correct answer there. And then the last question, what's he modeling? And it looks like all of you got it. It is a planet and a moon, which is pretty cool. You need a pretty big, like you have to have like table size thing to get it to work like he did. But any questions or comments on that demonstration? How many of you want to go out and buy like a giant sheet of spandex and try to get this working as a, I think this would be a fun thing to like try at home. I feel like you'd need like a glass table and like break the glass out of it or remove it so you have that like ring, and then you could tie this to it. So anyway, I am going to have you do something like that, but we're going to try to do it on a much smaller scale with whatever you have at home. So the next task, and again, I'll just share my screen here because it's easier for me to look over this with you together, is a Flipgrid assignment. So sorry if you're getting sick of these, but I think it's just good to get you away from your computer and doing stuff. So I would like you to click on the Gravity Visualized Flipgrid. This is under step 5. It'll take you to a assignment where, as usual, I've got what you need and what you need to do. And so essentially, you're on the Flipgrid. If you see this little picture here, you're going to be doing what he did in that demonstration, but on a smaller scale. So you're going to grab a big bowl or a big pot or a frying pan or something you have in your kitchen or somewhere else that's kind of large and round. Grab a t-shirt or a towel, or if you've got even cellophane wrap, you know, like sandwich wrap, you can put that over it and you can clip it down, or get a belt and belt it down, or string, whatever you can find at home. And then, you know, you can use a heavier mass and a lighter mass. That doesn't always work well at this scale because it's so small. So as you can see in that little image there, this is a video you can watch of me doing it, but you can just press into the middle with your finger, or if you want to get like a knife or a fork or a pen or whatever, press into the middle. That's your source of gravity, and then get something round to spin around it. You have a marble in your Science2 kit, so you can grab that marble, or you know, if you've got a grape or something that you could just roll around it. I've seen students get pretty creative with that stuff, but there's a demonstration video you can watch, and you just need to do that and post to the Flipgrid. You need to do 3 things in the video. Once you've got it all set up, you need to do exactly what he did in that demonstration video we watched, where place your object on the outermost edge and just let go and show that it falls to the middle, right? That's the attraction of gravity pulling the small object to the larger object that you're pushing into the middle with. And then do the same thing, pick up your small round ball again and launch it sideways. Give it some tangential velocity and see if you can get at least 1 full rotation. Again, this won't be a perfect thing because it's on such a small scale and so awkward, but just see if you can get it to go around at least once. That's your orbit. And just give a kind of brief explanation of what you're doing. Questions on that? All right, again, all the instructions are there. There's a demonstration video you can watch. I'm going to time for 20 minutes to do this. Let me know if you have questions. If you do finish and there's still time, you can move on to the next task, which is a little Canvas discussion board, but I'll talk more about that after 20 minutes. So go for it.